Okay, today we're looking at section 2.4 from our textbook, the graph of y equals kx. And you can see we have 4 learning goals. A couple of them sound familiar. Some of them are based on variation, the new part of this chapter. Others similar to something we learned in Algebra 1. So, getting started. You should know from Algebra 1 and from this year already that slope is nothing more than the change in y over the changes in x. And a lot of you have it memorized that m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, in an ordered pair, it's good if you're working with an ordered pair, let's say 3, 2, and the point 1, negative 1, and we wanted to know the slope of the line that they're on. When we say y2, y1, it means you pick out which ordered pair you want to go from. You truly could do the ordered pair negative 1 minus 2, y2 minus y1, or, and then x's, same order, 1 minus 3, or you could do 2 take away a negative 1 over 3 minus 1. Both of them will give you the same answer. Up on top here you can see we get a negative 3. Here we would get a negative 2. That'll give us a positive 3 halves. Here we will get a 3 up on top and a 2 on the bottom. We will get a 3 halves right away. So both of them give us an answer of 3 halves. It does not matter which point you designate as your first point versus your second point. It does not matter. It can go either way as long as you're consistent. The other way we've learned and talked about slope is rise over run. So on a graph that really helps to think of rise over run. The rise obviously is the up or down movement, because we can say negative rise is like falling, and then run is your left or right movement. So those are 2 key pieces. Nothing's going to change when we talk about graphing a direct variation equation in the form y equals kx. So let's look and compare what we've done in the past. Sometimes if I gave you a y equals mx plus b equation, let's go y equals 3x minus 2. I would ask you what's the y-intercept and what's the slope. You should be able to just look at those. No necessary values needed. However, some of you did learn to graph by picking values, and so we say always pick, for example, a negative number, a 0, and a positive number. I wouldn't go too big just because your graph paper is not huge, but if we did these numbers, now one at a time you replace them. Put a negative 2 in for x. 3 times negative 2 is negative 6. Negative 6 subtract 2 is negative 8. Put a 0 in. 3 times 0 is 0. 0 take away 2 is negative 2. And lastly, put a 2 in. 3 times 2 is 6. 6 take away 2 is 4. And if you then graph on an ordered pair xy axis, you should be able to place your points where these values are. So if we're assuming everything's 1 here, then we'll go to the left 2 and down 8. 1, 2, 3, 4, 5, 6, 7, 8 puts our point approximately right there. I need to calibrate the board a little. And 0, negative 2, don't go left or right. Go down 2, puts us there. And lastly, positive 2, 4, to the right 2, up 4, puts us about right there. You should be able to then draw a straight line through those points, put arrows on the end of it, and be good to go. Draw that line, arrows on the end of it, make it straight, make it go past those first and last points, and you have a good representation of your line. Okay? That is one way to graph them. We're going to talk about the quick graph method also, but before that, let's characterize these 2. If I said over here, our review one, you should be able to list some characteristics about them. For example, number 1, m is what? Number 2, b is what? We've already agreed that it graphs into a line. There's one of them. So fill those in. Do the same thing over here. You should find some characteristics. I want to see that list of characteristics when you come to class. The key is that if you put these two equations parallel or next to each other, and I'll do that like this, you're going to see some similarities. You should be able to talk about those similarities and write some of them down so you don't forget. So, knowing that we have similarities, we're saying that this form, y equals kx, is a special form of a line. And if we talk about y equals mx plus b, now that you have yours written down, I hope, you should be able to tell me m is the slope. M is that steepness, slant, whatever you like to call it, of your line. B is the y-intercept, where it crosses the y-axis. On this one, you better tell me k is lined up, and so k is equal to my slope. Some people will also say it's the constant of the variation. Well, yes, if we're thinking about a variation equation rather than a linear equation. But we can now say k is in the same position as that slope value. Second statement we can say, our y-intercept is 0 on every single one of these. When you have y equals kx, the only thing we cannot see, if I had something, the only thing that we cannot see is a 0. If it was a 2, a 5, a negative 1/2, we would have to see that. We can't guess at what y-intercept we have. We'd have to see that in the equation. Y equals kx definitely graphs into a line also. So we are seeing two forms of a line, one being our variation and one being our slope-intercept form. And so now every time you see this y equals kx, you should tell me, oh yeah, k is the slope. So you should know that a positive slope always slants up from left to right. A negative one always slants down from left to right. So by looking at a line, you should be able to tell me what type of slope it has immediately. You should also be able to tell me if it's a variation form, y equals kx, because it has to go through 0, 0. The y-intercept is 0. Over here, these do not. So make sure you look at that. Make sure you have some discussion, questions about that. And if you do, make sure you bring those questions to class. All right, that's all for today.